Today we're going to look at solving a system of equations using graphing as our method of determining the solution to the system. When we talk about the solution, we are talking about where the graphs intersect with each other on the coordinate plane. We're looking for one single point. In today's case, we have the equations y equals 1/3 x plus 1 and y equals negative 3x plus 11. Commonly, we will see a brace around the end of these two equations to represent that they are related to each other as a system of equations, meaning that they are both graphed on the same coordinate plane and have some kind of interaction with each other. We need to recognize what format they are in so that we know our best method to set them up as a graph on our plane. I see right now that they're set up in y equals 1/3 x plus 1. This is nice because I recognize that this is the same format as slope-intercept form, y equals mx plus b, where m is my slope and b is my y-intercept. The slope indicates how my line changes over time as a ratio of change in y over change in x, or rise over run, and b as the y-intercept, where the graph will cross the y-axis. One thing that I use to help me remember how to graph my line is I think about the b as the word begin. This helps me to know I'm going to begin at that point on the graph. So when I look at y equals 1/3 x plus 1, I'm going to begin at plus 1. So I'll go ahead and mark a point right there. When I come back and look at the m, that helps me to know the ratio of change or how my line will move across the plane. So again, going back to our y-intercept, beginning here at positive 1 and then moving at a ratio of 1/3, or rising positive 1, going up because it's positive 1, and then positive 3 of run means to the right. 1, 2, 3. And here's my next point on my graph. I can continue that pattern and I will see a constant pattern of rise 1, run 3. And what I'll notice is that my data will appear to be making a nice straight line. So there's 4 good solid points to make that line. Now let's think about my other equation, y equals negative 3x plus 11. I probably should have done that one in blue, but we'll go ahead and go to green for that one. I'm going to start with positive 11 as my beginning point, my y-intercept. And then I'm going to move based on the number negative 3. Now, negative 3 doesn't appear to be a fraction at first, but the cool thing about any integer is if I just make it a fraction over 1, it doesn't change its value and it's represented as a fractional value. In this case, I can see rise negative 3, run positive 1. So I'll follow that same pattern and I'll go all the way until I cross this line. Wherever this line intersects with the green line intersects with the blue line is going to be what's called my solution to the system of equations. So we're going to rise from here, negative 1, negative 2, negative 3, and then run positive 1 for a point. Do it again. Rise negative 1, negative 2, negative 3, another point, negative 1, negative 2, negative 3 to 1. Okay. That's cool right there because that's where I know that these two lines will intersect. We have a common point. Again, negative 1, negative 2, negative 3 over 1, just to be sure I've got another point. And I see a nice pattern that's developed. Pretend these lines are straight. Oh boy. Hopefully you get the point that this right here is the intersection right here at the ordered pair of 3, 2. I can verify that this is right by substituting the x value and the y value back into the equation. 1/3 of, if it was 3, is 1, and 1 plus 1 is in fact 2. And negative 3 times 3 is -9. -9 plus 11 is in fact +2. I know that my solution of 3, 2 is definitely correct for this system of equations. Hope this helps you.